So I've just taken delivery of the Sainsmart Genmitsu Proverxl V2. I don't know a huge amount about this machine at the moment, other than it's the newer version of the Proverxl that is behind me. But obviously the first thing that we need to do is get it unboxed and get it built. So that didn't take long at all, and first impression, well, there's not actually a huge amount to build on this machine. The bed and the base is already assembled, the X-axis gantry already assembled. There's only one or two things we've got to bolt together, get the wiring in place, and this machine is done. So well done, Sainsmart, on another easy build. I will quickly just mention my friend blue Loctite that clearly wants to jump off the X-axis gantry. This is a bit like glue for your bolts. You can use a couple of drops of it when assembling the machine, and it just guarantees it's going to hold everything together nice and tight. Use the blue one though, not any other colour, but it's just something to consider. The other quick thing I will also mention, this is technically a pre-production unit, which means there may be one or two small things different as I'm assembling mine than the ones you actually get when this all goes live. But with that out of the way, well, let's get stuck in and get this build done. Spend the first few minutes checking the contents of your box matches what is listed in the instructions. Then also spend a couple of minutes just going around checking that every bolt you have access to is in fact actually tight. Next we'll do a quick check just to make sure the frame is in fact square. Take a tape measure, measure corner to corner diagonally, take that measurement and then check it the opposite way as well and make sure they do align. Now, if for any reason this is not perfectly square, what you can do is slacken off some of the bolts holding the plates and just move this slightly to get it in place. But straight out of the box, mine was perfectly square. Next, we need to make sure that the two carriages are the same distance from the back of the frame. We can adjust these using the 7mm socket that is provided, putting it in the front and turning them in order to adjust them back and forth. Now we can either set the measurement with a ruler and check that they are the same distance apart. What I find easier is to take a solid object, place that into the gap, make sure it is sitting there, and then just turn it until it butts up to that, and that we know it is a set distance. We can then do exactly the same on the opposite side. Make sure that is touching that one as well, and we know they are now the same distance from the back of the frame. Next we're going to bring in the X-axis gantry. Now the limit switch needs to be on the back of this. There is a little recess on the side plates in order for this to slide in place, and there is also a resting bracket on the side of each Y carriage axis. So we should just be able to drop this in. You may need a little bit of a wiggle if it is tight, but it should sit nice and easy in place on those brackets. Take the M5 14mm cap screws and start to put those in place on the side of each Y carriage in through the brackets. Take the M5 16mm bolts and preload them with washers. The spring washer goes on first, followed by the flat washer. We're about to attach the Z assembly and the spindle to the X-axis carriage. Now there is a bit of weight to this, so if you're struggling to hold it in place, perhaps consider propping it up to the correct height with something like a book or anything else that will hold it in place. Now this may seem slightly fiddly because the bolts come in from the back of the plate. So place one in, bring your Allen key in and pass it through the bolt to hold that in position. Then take the assembly, line it up with the thread, and at least try and give it a few turns to get it in position. Now once you've got one in, it will spin about, but take another one and do exactly the same and get that one in position as well, and it should then all come together and hold in position nice and easy. There we are, so two bolts in now, it's holding pretty well. We're going to take the other two bolts, put those in the bottom. One thing to bear in mind at this point, don't tighten them up too much. There is a little bit of play in it and we'll want to check the how parallel this is to the board before tightening everything up. So all four bolts are now in place. The bottom two was more fiddly. You have to get underneath and kind of align the holes to get them in. But they are pinched up, but there is a little bit of play left in the Z assembly. Now I'm just going to bring in a square, and what we want to do is make sure this is touching and nice and square against this so that there is no gaps. That is looking pretty good. So what I'm going to do at this point now is just go around and pinch those bolts up and make sure that stays nice and square. Next, we're installing the X-axis motor onto the side of the gantry. To do this, we'll need 4 M4 12mm bolts, and we'll also need the coupler. Now, on the bar coming out of the stepper motor, there is a flat section, and on the coupler, there is a grub screw that goes straight the way through. Slide the coupler over so that grub screw is sitting on top of the flat area. If it doesn't go on to begin with, just slacken that little grub screw off slightly, put it in position, and then tighten that grub screw up till it grips the flat area of the bar. Then turn it over and just tighten up the other bolt to make sure that it's clamped on nice and tight. What you'll want to do now is when we come to install it on the side of the motor is just turn that around to make sure that the grub screw is facing outwards. We're then going to slide the coupler in place over the end of this bar. Now, if you find that the coupler hits the nut before your stepper motor hits this plate, just move the coupler down this bar a little bit further. So I've got a couple of mil gap there, and it just means that this should slide over and touch the plate ultimately before it ends up hitting that nut. So once that is in place, bring in your M4 12mm bolts and start to put those in place and get the motor held in position. Once the stepper motor is secured in place, come in and tighten up the little grub screw to make sure it engages with the bar. Then twist that around a little bit. You should just about be able to do this with your finger, and tighten up the clamping bolt as well. You want to make sure these are pretty tight, but don't over tighten them too much because they are a fine thread. Next, we're going to install the drag chain brackets. There are two brackets that look very similar. The X-axis is the taller one, the Y-axis is the shorter one. We're going to start with the Y-axis first, so we'll get rid of the X-axis one for now. We're going to be using the M4 6mm bolts and the M5 12mm bolts to hold both of these brackets in place on the side of the machine. The L-shaped bracket is first, and this is using the M5 12mm bolts. So we just place that through, align it with the holes in the extrusion and tighten them up. Get one in place, bring the other bolt in, get that in place, and then square up this bracket a little bit, move it over slightly and pinch it up. The second bracket gets fixed in these two holes here. Be careful not to damage any of the wiring. So we're just going to place one bolt through the hole and then try and get that in place. Again, before securing the second bolt in place as well. Once both are in, just make sure they are pinched up and holding the bracket securely in position. Next, we'll install the two brackets for the X-axis. The smaller one goes towards where the stepper motor is. There is a little bit of a curve on the bracket. This should face into the machine. And again, we'll fix this in place using the M5 12mm bolts. We'll just drop this in and fix it to the extrusion. And then we'll secure the other bracket to the rear of the Z assembly. We're about to put the drag chains and wiring loom in place. This is probably the most fiddliest of the process. There are two ends to the drag chain. One is where all the longer cables come out with all the aviation connectors. The other one has the smaller JST connectors. Now, the end with the aviation connectors, this will start at the back of your Y-axis, and then it'll essentially thread round up and over and up onto the X-axis gantry. I would suggest trying to get it roughly in place first before fixing any of the drag chain down, and that's what I'm going to do now. So with that sitting roughly in place, I'm going to bring in the M4 6mm flat cap bolt and just go around and secure each end of the drag chain to its fixing point. So with all the drag chains and wiring loom in place, we're now going to go around and make all the connections. Now, each cable is clearly labelled up for what it is for, and also each connection is separate to the other one. So there are different types of connectors. It makes it very simple to go around and connect this machine up. Now, a new addition to the V2 is something that are called eccentric nuts. These sit on the wheels underneath each carriage and ultimately allow you to adjust the pressure they are applying to the extrusion. So for example, if your carriage is a bit wobbly, you can tighten them up. If it is too tight, you can slacken them off to allow it to run smoother. In the example we've got here, the Z assembly is a little bit wobbly. So I'm just going to come in with the wrench. And these only work on basically half a turn one way or the other. And I'm just going to pinch that one up a little bit. And it's now just taken some of the wobble out of that. I'll do exactly the same on the other side as soon as I can get round to it. And now we have the wobble has now been taken out of it. If you have similar scenarios on the Y-axis as well, you can do exactly the same. They have eccentric nuts underneath the bottom. Just a quarter of a turn, normally one way or the other, will either tighten them or loosen them and make it run smoother. We'll do all the connections on the back of the control box. Again, the labels match all the markings on the back of the terminals. So we'll go ahead and get all of these in place now. Take the connector for the Z probe, release the screws a few turns, and you'll start to see that the holes inside will open up from the top. Once you have sufficient gap, take the cable for the Z probe, slide them into those holes at the top, make sure they're in there nice and secure, and then tighten both of the screws back up. It should clamp those cables in place, making it ready for you to use your Z probe. Connect the USB cable. Connect the Z probe connector. Make sure the switch is set to spindle. Release the E-stop. Connect the power cable. So now we've moved over to your PC or laptop. At this stage, it technically doesn't matter if your CNC machine is turned on or not. We're just going to do the necessary steps to allow them to talk to each other. Make sure your USB cable has been connected to your PC or laptop, and also plug in the USB thumb drive that came supplied with your machine. It should pop up and show you a window similar to this with a few folders, or it may appear down here on the left hand side. If for any reason your thumb drive is corrupt, you can always head to Google, search for Sainsmart resources, and it will probably show you the Proverxl 4030 resources. Now the files for the original 4030 are also the same for the V2 one. So we're going to come back to the USB thumb drive now. The first thing that we are going to do is go into the driver folder. There are obviously files for Mac or Windows. I am a Windows user, so we're going to go into this zip folder. Now, depending on your system, you may see different windows pop up, but ultimately it should open up this. Head into the folder that says ch341ser, and we can then come down to the setup exe file. Now, in between clicking that file and this window appearing, you may have a security message pop up. Just click yes and proceed through, and then this window should appear. We're going to click install. It will take a few seconds for this to run through. And once it is successful, we will get a confirmation message. Now, if your driver fails to install, it is probably because you have not connected your USB cable. So make sure that is done and then proceed with the driver installation. As this has been successful, we will click OK. Then close all this down and go back to the original folder. And we're then going to go back up to one level. Now, before we go into any of the software, we just want to do a quick test. Select your Windows key and type Device Manager. It should appear at the top. Open this panel, and we simply want to head to the Ports menu. Expand this out, and you should see something now that looks like this: USB serial CH340. Make a note of the COM number that is next to this. Mine says 4, yours may say 5, 6, 7. It may have a different number. Don't worry about that. Just make a note of the number that you do have next to this, because it is important. We're going to close this window down and then head to the software folder. Now, in this folder, we have two pieces of software, Candle and Universal G-Code Sender. They essentially both do exactly the same thing, which is controlling your CNC machine. It is just personal preference which one you use. I prefer Universal G-Code Sender. It gives you lots more options in order to run your machine and do various things. Candle is a bit more basic, but some people prefer that, not to have as many options available. To begin with, I will show you how to connect your machine using Candle, but I'm then going to move over to Universal G-Code Sender just because I prefer that software. So to begin with, let's go into Candle and we're going to open up the Windows version, head into the folder, and then we're going to open this file, GRBL control Candle, and we'll maximize this up. Now at this point, if you haven't turned your CNC machine on, do make sure you do that. Now what we want to do is tell this machine what COM port to use in order to connect to the CNC machine. So we're going to come up to Service, we're going to come down to Settings, and then where we have COM port or port COM3, we're going to change this to number 4 because that's what my machine was. If yours is a different number, remember to change it according to the number on your setup. Now by default, the baud rate should load as 115200. If for any reason yours is showing a different number, make sure you select this one, 115200. Now we've basically just told the machine what port to connect to in order to talk to the CNC machine. So we should click OK and it will connect to it. Now we can see a few things happen. We had some messages pop up over here. Don't worry too much about this, but we can also see there is an alarm message. Now this machine has limit switches, and as a safety feature, whenever you start the machine, it will just go into an alarm mode, and ultimately all you have to do is simply click the unlock button and you're good to go. Now at this point you are technically connected to your CNC machine and you can start to move things about. The step size is how far you want it to travel. This will primarily be in millimeters. So what we're going to say is let's just do a quick test. 50 millimeters. The feed rate is how fast do you want it to travel. So we're going to take this up a little bit and maybe take this to 2000. So what we've basically said now is any of these arrow buttons that we click, move it 50 millimeters at a speed of 2000 millimeters per minute. So let's test that out. There we are, every axis is working. And ultimately, if you want to test the spindle, we can click this little cog icon here. So everything is running as it should within Candle. We will quickly do the same test in UGS now. I'm going to close Candle down, close all these messages down. We're going to go into the UGS folder. Now we could do the same. I do already have UGS installed on my machine, so I'm simply going to open that to save any conflicts. Now if you open UGS up and it doesn't look the same as this, don't worry. One of the joys of UGS is you can move things about and customize them however you want. All of these different tabs can be clicked, dragged around and repositioned, dropped back in different places, and ultimately you can build this out however you are comfortable operating with it. And also any of these tabs can be turned off and back on. So let's say, for example, on the jog controller, we're going to click X, get rid of it. We can come back up to Windows, plugins, and turn it back on. So ultimately, it's much more customizable for the user to lay it out however they feel comfortable. But the principles of it are exactly the same. Now up the top here, we can already see the port is set to number 4. If you're not seeing the number that you need in this box, simply click the refresh button. Then go and select the COM port number that you need. Again, the baud rate is on 115200. There will be other options, but this is the one that we need. You'll need to make sure the firmware says GRBL, and then basically we do the same thing and tell the machine to connect. And there we are, the machine is connected. Now we can see exactly the same way as it did in Candle. We've got this alarm message. So all we need to do to get rid of that is click the unlock button, and everything comes back to life. Same principle again with all your jog controls, the step size and the feed rate. Now one of the reasons I prefer UGS is because you can set different measurements for the X and Y instead of the Z. So for example, we may want the X and Y to travel 100 millimeters, but we may only want the Z axis to travel 10 millimeters at a time. So therefore we can move this about, jog it back, but with the Z axis we can move it in smaller increments. So that is a successful test. We have got the software connecting to the machine and we can jog everything about and make sure all the axes are actually working. Now, just as a quick tip, UGS doesn't have an on and off button for the spindle, because to be honest, in usual life, you don't really need this. But if you do want to test it within UGS, come to the console box and down to the command line. Now, if you can't see the console box, again, head up to Windows and you'll see it is here. Just select it and turn it on. In the command line, we're going to type M3 space S10000 and simply hit enter. And to stop this, we'll type M5 and hit enter. Now, if for any reason your spindle doesn't turn on, make sure that the speed control on the side of the control box is turned up to full. And as one final tip, if you are new to CNC, you may hear people talk about your Gerbil settings or your GRBL settings. In order to find these out, again, come to the command line, and this works the same in UGS as it does in Candle. Type $$ and hit enter. This will show you a list of settings that are all about controlling your CNC machine. And these are ultimately, if you ever need to find them, this is how you get to them. So at this phase, you're hopefully thinking, James, that went really smooth. How do I move on and start doing my first test cut? Well, on the thumb drive, there should be some test files, and there's also a link up in the corner to a more comprehensive video for moving on to the next stage. It covers some of the things we've just gone through, such as connecting your machine, but crucially, it moves on to other things such as how to clamp your material down correctly, how to install bits in the spindle, and well, ultimately, how to get your job up and running and get your first test cut done. So definitely check that out when you're ready to move on to the next phase. I do hope you found the video useful. If you did, please give it a thumbs up and like it. Please also make sure you subscribe. Thank you all very much for watching. Final thanks as always goes to my patrons. If you want to get involved for one-to-one help, early access to content, and also giveaways, then check out the Patreon links in the description area below. I will see you all on the next episode.